Okay, welcome everybody. So glad to have you here. We're going to get started. My name is Jason Jay. I'm a senior lecturer at MIT Sloan and director of the Sustainability Initiative. And what we're going to do is we're going to solve climate change in an incredibly short period of time. What is the problem that we're trying to solve? We need to get emissions down from the current business as usual trajectory, where we will be in a 3.6 degrees Celsius warmer than pre-industrial levels, down to a future where we are 1.5 to 2 degrees Celsius above pre-industrial levels. Why is that the goal? Why does that matter? Well, the Intergovernmental Panel on Climate Change, which is a consensus science organization from all around the world, drew this map of the risks to climate change. You are here. We have already warmed up the planet 1 degree Celsius above pre-industrial levels. And we will have, the projection suggests that business as usual, we will be 3.6 to 5 degrees Celsius by the end of by 2100, by the time that my children have children. Right now, we are already seeing detectable impacts and risks: dryland water scarcity, wildfire damage, tropical crop yield reduction, and food supply instabilities as a result of that. If we go towards this business as usual future of 3.6 degrees, we will have very high risks of severe, irreversible impacts with limited ability to adapt. Scientists don't like to use words like catastrophic, but that's about as close as they get. So this is the future that we're heading into. And as somebody who has a 10-year-old and 7-year-old child, and I'm thinking about the future that we're creating with them, it's very clear which part of this picture I want us to be on. So the challenge is, how do we get emissions down? Now, one major answer to that question has been the Paris Accord and the incredible collaboration of more than 180 countries working to reduce their emissions. The challenge is, and agreeing to 2 degrees or 1.5 degrees as the aspirational target. But the nationally determined contributions, the commitments made by countries, only add up to emissions reductions that get us to a 3.3 degree future. And that 3.3 degree future is still deep in the red-purple risk zone of this risk map. So we've got to do a lot better. How do we reduce emissions on that kind of trajectory? Well, and how can I engage you as our audience, as our alumni, to help make that happen? Well, it's not going to be just by showing you more charts and graphs and talking at you more. As John Sturman, our colleague, is fond of saying, research shows that showing people research doesn't work. If I just give you that information and data, it's not going to motivate you to take action. It's not going to help you understand the urgency, and it's not going to help you refine your mental model about the climate system. What is going to work is interactively exploring these dynamics for yourself with a simulation tool, and that's exactly what we're going to do. Now, the way we're going to make this interactive with the many people that we have here on the call is that we're going to use a tool called Poll Everywhere. Poll Everywhere will allow me to pose a question to you, and then your answers will show up here on the screen. So I want you to go to the URL that is on the top of the screen, pollev.com/btgbook. And what that will do is it will, the question will show up on your screen. So you're going to do this in the separate browser tab or on your mobile phone. And when you put your answers into the interface, they'll show up here real time. One thing you'll notice, the first person who wrote said Santa Barbara. Now Santa and Barbara are getting separated from each other. If you want things to show up as one thing, put a hyphen in between them. But as we do this, I'd love to get as many, I want to get everybody in here. So I've got 16 results. Let's see if we can get to 17. We've got 18, we've got 19, 22, 21. Excellent. We're going to be doing this with climate change later, so get used to it. 24, 25. Excellent. We've got 62 attendees. I want to see everybody's on here. We've got people in Cambridge, Boston, Montreal, Philadelphia, Bar Harbor, Taiwan. Really appreciate you being here from Asia. The West Coast of the United States. We've got Florida. We've got New Haven, Connecticut, obviously close by. Houston, big energy community there. Love to have you. Bogota, Colombia, excellent. Love the spread across the United States and globally of the group that we've got here. And again, this is just sort of a test poll to get us using the technology so you can see how this kind of word cloud interface works. Now, here's the question. Here's the first sort of real question after this quick warm up, which is, how are we going to solve climate change? So what I'm going to do is I'm going to put up the next poll. So your screen should refresh automatically with the new question that I'm posing, which is, what action will help us solve climate change? I want to know your thoughts. And again, one word or, hyphenated pairs of words if needed. And I want to get everyone's ideas. Whatever style or format of idea you think, fix the global food system, veganism, keep it in the ground, meaning keep those fossil fuels in the ground, don't burn the carbon and put it in the atmosphere, individual education, beeflessness. I love beeflessness. That's not veganism or vegetarianism, but it focuses right on the most carbon intensive food in our food system. Carbon capture, carbon removal, reduce energy consumption ASAP, decarbonization, renewable energy, cheaper solar, atmospheric carbon. I just love the word less. So use less energy, less of everything, electrification. Okay, so I want to point out a couple things about this picture as it's emerging, and I want your answers to keep coming in. If I'm a policymaker, or I'm a major investor or someone else who's got some levers to pull, I have about this much bandwidth for thinking about the world. So imagine, I'm a senator or I'm in the Biden administration. I've got to think about stimulus bills, inflation, education policy, national security, international relations, and I've got like this much to think about the environment. Within the environment, I've got to think about water pollution, air pollution, plastics in the ocean. I've got this much time to think about climate change. So now within this little band of bandwidth that I've got, I say, okay, how are we going to solve climate change? And this picture is the answer that I get. I've got all kinds of technologies, policies, behavior changes. It all sounds reasonably good. I'll pass one bill with one of these ideas and then move on, and I'm done with climate change for the year. That's not a good enough answer, and it's also not what's going to help you make sense of this complexity for your own lives and your own work and your own work and investing. So what we're going to do is we're going to use an interactive simulation tool called En-ROADS, which is developed by MIT Sloan School of Management together with Climate Interactive, which is a nonprofit, nonpartisan organization. And under the hood here, there's 14,000 equations, system dynamics model. So these are a system of differential equations that are parameterized to the best available science. So everything is based on peer-reviewed science. You can look at the technical documentation. And the whole thing is calibrated to behave the same as the big supercomputer models that take months to run, except I'm going to be able to pull levers and it will instantly see what the results are on the mix of our sources of energy, coal, oil, natural gas, renewables, biofuels, and nuclear, the greenhouse gas emissions from land use, energy, F-gases, methane, and nitrous oxide, and then ultimately what's going to happen to that temperature number. Remember, our goal here is to get that number down to 2 degrees or 1.5 degrees above pre-industrial levels, because that's the global goal to get to a safer future. So let's take a look at your ideas. The size of the font here correlates with how many people sort of suggested that idea. So I'm going to start. I'm not sure exactly how to interpret less, so I'm just going to go with electrification, which is kind of the next biggest thing. So let's look at electrification. We've got two different electrification levers here. We've got one for transportation, which is going to be electric vehicles, Teslas for everybody, and we're going to have electrification of buildings and industry, which is going to be things like air source heat pumps to replace gas boilers. So let's try these. When I pull a lever, I want you to form a hypothesis in your mind. When I push the button, what is going to change? How big is the change going to be? Ready? Here we go. I'm going to electrify transport first. What's going to change on the picture? Okay, I hit the button, and let's rewind so you can see what happened. That changed a very significant ramp up of electric transport, and this is globally. This is a globally aggregated model. What we see here is we reduce our oil consumption because oil is the transportation fuel right now. So we're going to reduce our oil consumption, and we're going to power our cars in part by some renewable energy. So you're seeing the green expand as more demand for that solar, but we're also increasing our demand for coal energy in this situation. And that increase in coal is going to offset a bit our gains in emissions. So we're going to see a little bit of change here in our energy greenhouse gas emissions, and it's going to get us to just shy of 1/10 of a degree Celsius. So some of you are saying, wow, that's a bigger change than I thought it was going to be, smaller change. Great. We can talk more about why that is. It takes time to ramp up the electrified vehicles, but most importantly, we're powering them with brown energy. Let's try electrification of buildings and industry. Here, what's going to happen is we're going to substitute away from natural gas, which is a very significant heating source. as well as some coal. And that's actually going to be worth 0.2 of a degree Celsius. So actually a more significant impact in electrifying buildings and industry than we get out of transportation, precisely because and these things are piling on top of each other because we're substituting away from both oil and gas here. We're still loading up on coal a bit, and that's why we're not seeing as big of changes, but clearly we're adding more renewable energy to power this stuff. So let's look at some other stuff. Let's look at the next biggest thing is probably carbon capture. So let's grab that carbon and put it into the ground. Now, carbon capture and carbon offsets are often sort of used interchangeably. There's a few different ways that we can think about getting to offset our carbon and get to kind of net zero as opposed to zero emissions. The most common way that people use to try to sequester carbon is planting trees. That is the most common carbon offset in global voluntary markets for carbon offsets. So let's start with that. So I'm going to plant trees. We have this concept of a trillion trees initiative. I can take the percentage of land available for afforestation, and we're going to just crank it. We're going to use 75% of all that land. We're going to plant new trees on it and use that to grab carbon. Ready? Form of hypothesis. Here we go. Boom. That was worth another 0.1 of a degree Celsius. So growth of trees takes a long time. We've ramped up here to the point where we've got about 5.5 gigatons a year of CO2 being sequestered by those trees. We've taken land use emissions from a net source of emissions to a net sink. It's below the zero line. But the problem is we are trying to put 5 gigatons away in the trees while we're still emitting 44 gigatons from our energy system and roughly another 20 gigatons of CO2 equivalent in other greenhouse gases. So maybe when you said carbon removal, or carbon capture, you didn't just mean planting trees. You also meant some other technologies for carbon removal. Let's look at some of these ideas. BECCS, direct air capture, enhanced mineralization, soil carbon sequestration, biochar. These are all the technologies. Let's say that we invest in a portfolio of these and get to about, let's say we get to 50% of our technical potential on carbon removal, and that's going to get us another 0.2 of a degree. So again, now we've got a bunch of negative emissions here, but the size, the magnitude here is just not big enough to offset the emissions that we've got on the board. So now you've started to get a feel for the kinds of things that we can play with. I want to get you kind of like your hands on the model a little bit more. And the way we're going to do that is I'm going to go to another poll. This poll is an image poll. So what's going to happen when your Poll Everywhere screen refreshes is that you're going to get this picture, and you can just tap on the levers that you want to pull. It'll give us a count of how many people are tapping in those boxes, and basically the most voted levers are the ones that we're going to pull. So far I've got about 4, 5, 6, 10 folks joining in. Let me just keep track of how many people we've got responding. Okay, so I've got 19 people responding, 23, 24. We've got 72 people here in the room. I want everybody to vote. What action do you think is going to be higher leverage than the things we've tried so far, which were electrification of transport, buildings, and planting trees? So we've got 8 people, 9 people for nuclear energy, 10 people. We've got 7 people wanting to shut down coal. We've got people interested in methane, carbon pricing. Let's keep those flowing in. We've got 36 ideas. The other 35 of you, if you don't know how to get to the poll, the URL is at the top of the screen. You can also look in the chat where you'll have a clickable link to the poll, and would love to get some more ideas in here. Okay, so now we've got a lot of people interested in nuclear energy. Let's take a look. Nuclear energy is advancing. We've got smaller scale reactors. We've got better fuel cycles. So maybe that's going to help us out. So what we can do here is we can essentially ramp up nuclear energy. Now, one thing I should have said earlier is when we pull a lever here, you can think about that lever as being pulled in a couple of different ways. There's you can think of it as public policy. You can think of it as where we've got a government subsidy for that form of energy. You can think of it as an investment lever where people with capital and who are asset owners are placing capital toward those technologies. Corporate action like 100% renewable energy commitments, or companies putting R&D money into nuclear, or even civil society action in the form of various kinds of public support. In this case, we'll pull this encouragement of nuclear energy and see what happens. Here we go. Boom. Okay, so that gets us another tenth of a degree of emissions reduction. So that's fantastic. Every tenth of a degree matters, gets us closer to our goal. Now, some of you, and we can look at what that means in terms of the ramp up of nuclear energy. We're putting a 6 cent per kilowatt hour subsidy on nuclear, sort of equivalent of that level of support. We have this massive ramp up of the amount of energy we're generating from nuclear, going from 10 exajoules to 230. So really a huge expansion of the nuclear energy industry. But it takes a long time to build these plants. This ramp up is not instantaneous. And what we see here is that, watch the energy graphs, right? We are substituting away for some of that coal that we're using to make energy, but we're also substituting away from some of the renewable energy. So the nuclear is displacing some of the solar, wind, and geothermal and hydropower that we've got in the grid, and that is somewhat attenuating its effect on greenhouse gas emissions. But with a very aggressive subsidy, we can get 0.2 of a degree out of that expansion of nuclear capacity. So great suggestion. Now let's look at what else we've got here. We've got 6 people wanting to work on coal, on reducing the amount of coal that we're going to use. Okay, so how are we going to do that? Well, if I open up the detailed settings for coal, there's a few ways that we can work on coal. We can tax coal. So we can sort of we can economically disincentivize its use. One of my favorite levers is just to stop building new coal infrastructure. We could do that through regulatory mandate. We could do that through choking off different forms of insurance, lending capital, and other forms of capital provision. So I'm going to pull this lever to stop building new coal infrastructure starting today. Keep the current plants burning, but let them age out. Boom. That by itself was worth 0.3 of a degree. We haven't pulled any levers that got us 0.3 of a degree like that. And that's because coal is the most greenhouse gas intensive form of energy that we have. The other thing that I want to show you about shutting off coal is that right now our impact graph here has been greenhouse gas emissions. Let's look at air pollution, which is about PM 2.5 air pollution, which has a big effect on respiratory health around the world. Millions of people dying prematurely from these kinds of causes. We stopped building new coal infrastructure, and we put a major dent in the air pollution because the vast majority of that PM 2.5 is coming from coal. So that turned out to be a very powerful lever. Oftentimes people like to focus on, this problem of climate change is all about stocks and flows. And oftentimes people think about the stock and flow of the atmosphere, right? The bathtub of the atmosphere. There's an inflow, which is the inflow of greenhouse gases from emissions, the outflow of carbon removal. But there's another stock and flow problem, and that's the stock and flow of our infrastructure. People often focus on the inflow to our infrastructure. Let's build more stuff, build more nuclear, build more renewables. But the key thing is the outflow of that stock. We got to shut things down so that we leave it in the ground. And that's what's happening when we shut off the coal lever. And that's part of why that's a very powerful lever to pull. Another way we can do that, that shift from coal, is to do carbon pricing. There's a few people suggesting that, but I have more votes for renewable energy. So let's take a look at that. So we're going to subsidize renewable energy. Let's give that a shot. When I subsidize renewable energy in our current picture pretty aggressively, we're getting another 0.1 of a degree out of that. So that's fantastic. Note that it is only a 0.1 of a degree. So some people might think, well, I thought we might get more out of that. But just notice that we already have a pretty tremendous amount of renewable energy on the board here as a result of our electrification, as a result of shutting down coal, and then electrifying everything. We just got a lot more electricity ramp up. And we're going to do it with the cheapest source we've got. And that cheapest source is going to be solar, wind, geothermal, and hydro as those cost curves come down. So we can encourage that even further. It's partly going to substitute away for some of that nuclear that we built. So these subsidies are partly competing with each other. If we look at the economic costs of those subsidies, we'll see that we're kind of ramping up a lot of costs without making any revenue back for it. So we might want to worry about that a little bit from an economic perspective. But the climate crisis is serious. Let's go after all of these policies. Now, the next thing that people voted for, but which we haven't yet tried, is carbon pricing. 4 people voted for carbon pricing. So carbon pricing is the idea that right now it's free for people to pollute, but it's costing all of us in terms of the dangers to our health, infrastructure, and society. So if we carbon price, we're internalizing the externalities and we're making it expensive to pollute. So let's try a carbon price. Let's do an ambitious carbon price of $100 a ton. When I push enter, the graphs are going to change. Let's form a hypothesis. That by itself was worth 0.3 of a degree. On top of everything else that we've already done, it's still worth 0.3 of a degree. We've already shut down new construction of coal plants. But what this is doing is it's accelerating the move toward, it's doing two things. Let me show you this on this picture. So this picture shows population times GDP times energy intensity times carbon intensity equals CO2 emissions from energy. When we pull a carbon price lever, so let me go back to 0, what happens is two things. One is that we're incentivizing the move toward green energy, which is this graph, but you'll see that there's also a bend in this curve. We're reducing our overall amount of energy use because of those incentive effects. We're getting people to adopt more energy efficiency technologies, mode shift from less to less carbon intensive modes of transportation. It's a very efficient policy, as people like Chris Knittel at MIT Sloan have proven out in their research. So we're at 2.2 degrees. We're doing fantastic. We're getting really close to our goal. Let's look at this methane and other gases, which is the next thing we've got 3 votes on, because while we've done a lot on CO2, we've captured a lot of CO2, now we're at a point where the majority of our greenhouse gas emissions at the end of century are from these other greenhouse gases. And so let's tackle the methane problem. There's 2 different sort of subsectors where we can do that. People talk a lot about cows and agricultural waste emissions. So let's do that through kind of the food waste veganism idea that came up in the poll. So we're going to reduce methane emissions from cows and other agricultural sources. That's going to be worth 0.1 of a degree. Energy and industry emissions is going to be worth 0.2 of a degree. Okay, so we're emitting a lot more methane from energy and industry, leakage across the natural gas pipelines and other chemical plants and so on, than we are from the agricultural and waste emissions. And now with those 2 changes, with that change to the methane system, we've gotten to 1.9 degrees. So in a very short amount of time, you've solved climate change. I want to congratulate all of you. And what I'm going to do is I'm going to paste our scenario into the chat so that you can click this link and pick up where we left off. And maybe you want to rewind some of the changes. Maybe you think these subsidies are going to be too expensive, or you want the carbon price to wrap in more gradually. You think some of these things are low leverage, we don't need to bother. All of that is your prerogative. I also encourage you, I noticed in some of the Q&A, some concerns about sort of climate skepticism and so on. And what I want to suggest you do is go to assumptions and just play with those assumptions yourself. If you think the climate isn't as sensitive to CO2 as the scientists do, you can reduce that. If you think that there's going to be feedback loops from the thawing tundra and it's going to be more sensitive, you can pull the lever in that direction. If you think the technical potential of carbon dioxide removal is bigger than we think it is, you can go ahead and pull that and get more carbon removal out of these technologies. The point is that this is a tool for learning, conversation, dialogue. We're using it with policymakers, we're using it with investors, we're using it with companies, we've used it with you, and I really appreciate your taking the time to play ball with us tonight and solve global climate change.